Hello everyone, this is Krishna from Sony, and in this video I'm going to analyze the style GAN2 results, specifically how the generated images change on changing some of the model parameters. Now if you're unfamiliar with style GAN2 model and how exactly does it work, I recommend you to check out the style GAN2 Colab demo run-through video, which is available on our channel in both Japanese and English. You can find the link to those videos in the video description. So let's get started with this video by opening the style GAN2 Colab notebook. As before, we will need to set the hardware accelerator as GPU in the runtime type. That's set, we save. Now we will install some of the required libraries and clone the nnabla-examples repository that contains the style GAN2 code. So now that's done, we will download the pre-trained style GAN2 model weights. The default link in the notebook downloads the weights for the model trained to generate human faces. Let us proceed with the human faces model for now, and we will also try out the weights for different other datasets later in the video. So now that's done, we'll come to the input configuration. Let us now analyze the effect of changing truncation psi on the generated images. First, let us increase the batch size, which in this case is the number of generated images. We set it to 4. Now, as explained in the previous style GAN2 Colab demo video, truncation psi ensures that the generated output is realistic by ensuring that the output of the mapping network is close to the mean mapping network output. So another way in which we can understand the use of truncation trick is as follows. The outliers or low density regions of the image space are unlikely to be properly learned or captured by the generator. So what we are essentially doing is that we are reducing the space from which we are sampling the latent vector around the space which is likely to be captured sufficiently well by the generator. Now, as the reduced or the truncated sampling space is likely to be well represented by the generator, we should see better quality of generated images, albeit at the cost of reduced variation. First, let us set truncation psi as 0. In this case, the mapping network output will exactly be the same regardless of any input, so we do not expect to see any variation across different generated images. So we first set it to 0. So these are the 4 images that are generated by the model. So you can see that we obtained the same 4 images, which is expected as the mapping network output was kept same for all the images. Now let us increase truncation psi to 0.2. We save this and we generate the results. Now you can see that there is some variation in the obtained faces, but they still look a bit similar. So we'll further increase truncation psi to 0.5 this time. So we can see that now we obtain considerable variation in the generated faces. Now we need to be careful about increasing the truncation psi to a much higher value. If we increase the truncation psi to a value close to 1, the generated images might look unnatural. Let's try that by setting the truncation value to 1. Now for a value of 1, we have now moved considerably away from the mean mapping network output. Let's see the results. So now we can see that the images have started to look slightly unnatural. We can see some weird patterns in this first image on the left and on the right. Here as well we see some unnatural elements here as well. So we can say that the value of truncation psi in the range of 0.4 to 0.8 works best for generated faces to have sufficient variability and also be natural looking. Now let us set truncation psi to a negative value and see the variations. Now as per the original style GAN paper, we should get something of an anti-image, or in other words, the image attributes should be opposite to the images obtained using the corresponding positive truncation psi value. So let us try that. Let us reduce the batch size to 1. And check for the corresponding positive truncation psi valued image. So we'll also reduce truncation psi to 0.5. Let us also change the latent seed for this example. We set it to say 500. Now we save the parameters. Now we run the generation script. So what we observe is the face of a man whose face is towards the camera, but in general seems to be facing the left side of the screen. Now let us set the truncation psi to a negative value of minus 0.5. It will show a warning, but it's fine. The warning is due to the range of the slider that we have set. So now what we observe is a woman whose face is towards the camera, but in general seems to be facing the right side of the screen. So the orientation and the gender changed on changing the sign of the truncation psi parameter. Now let us try with a different magnitude of truncation psi. This time we'll set it as 0.9. We run the cell again. So now we get is a man whose face is on the right side and his orientation is tilted towards the left. So let us change the sign, generate the result again, and as expected we get sort of an anti-image. We get a woman's face with exactly opposite position and orientation as the previous output. Likewise, you can try this with different truncation psi values as well. Now let us try generating images of other objects. For that we will have to download and load the pre-trained style GAN2 generator model weights for other datasets. For the list of supported datasets, we can check the readme of style GAN2 in nnabla-examples repository. You can see here. We can see that the current nnabla implementation supports generation from 6 types of datasets. Let us look at the image generation results of other types of data as well. So let's start with cars. For that we'll have to change the URL and load parameters line. Now that's downloaded. So then we'll set the parameters. Let us first see how the images look with the truncation psi as 0. Let us also change the seed to say 222. Let us also increase the batch size. Another thing to keep in mind is to take care of the resolution of the generated images, as style GAN2 model for different datasets have been trained to generate images at different resolutions. We can check the resolution of different datasets in the aforementioned readme. You can see that the car images will be generated at 512 x 512 resolution. We can change the resolution by passing the resolution argument to the generate function. Having done that, we'll run the code cell. So this is what we obtain. So we can see that the image corresponding to the average latent space output is not really natural looking, which can be a possibility as well. So let us increase truncation psi to 0.4 and check the outputs. Now we can see more natural looking images that have some variation as well. Let us further increase truncation psi to say 0.75 and check the outputs again. We can see that the variation has further increased. For truncation equal to 0.4, we mainly saw vintage sedan types of cars. But for truncation psi as 0.75, we are also seeing some open cars and some more contemporary cars as well. Now once again, as before, let us try negative truncation psi valued generation for the car dataset. Let us change the seed to say 660 and we'll set truncation psi to 0.8 and we'll again reduce batch size to 1 so that we can just mainly focus on the differences of the two generations. So we get an image of this rather contemporary car with dark color facing central left. Now let us change the sign of truncation psi and again generate the result. So what we now get is the central right facing white vintage sort of a car. Now this observation remains consistent with what we saw earlier. Changing the sign of truncation psi yields images with opposite properties. Now let us try the same drill for cat dataset. So we'll once again have to download and load the parameters for cat dataset. Note that the cat generator model is trained for 256 x 256 resolution. So we must be careful of changing that in the code cell. So we change the resolution here and we'll also change the display window size. So having done that, we will again check the results for truncation psi equal to 0. Also let us change the latent seed again to say 600. We also change the batch size to 4. Now we'll run this code cell to generate the outputs. So you can again see that we get the same image which corresponds to the mean mapping network output. So this is sort of the average cat that is learned by the model. So now we'll increase the truncation size to 0.25 and check the results. So as expected, we can generate cat images with limited variations. Now let us further increase truncation size to 0.6 and let's check that. And we can see that now we are able to generate superior quality images that also have considerable variations. Once again, let us try a negative truncation size value for cat generation. So let us again change the latent seed to say 765, change the batch size to 1, and let us set truncation size to say 0.25. So what we now obtain is a cat with dark color fur. The face of this cat is almost central, slightly towards left, while body is on the right side. Now let us change the sign of truncation size. So now you can see is that we get a cat with a central face but body on the left side. The fur color of this cat is also light. So we further verify that changing the sign of truncation psi changes the attributes in the generated image. In this way you can play around with the value of truncation psi to get more natural looking and less natural looking results, and also image results that have opposite set of properties.